So in today's lecture video, we're going to talk about many functional groups like alcohol, phenol, thiol, and ether, and then we're going to discuss it. What are those? How to name them, and what are the different properties and chemical reaction these functional group normally shows. So what is alcohol? So alcohol has a functional group whenever any hydrogen replaced by a functional group OH, we call that hydrocarbon as alcohol. So for example, let's say you have CH, H, H, and H. Then what's the name of this alkane? This is methane. You have 4 hydrogen across the carbon. But if I remove one of the hydrogen and put a functional group OH, then this molecule will become alcohol molecule because of this functional group, which is an OH. So if you if you see any functional group which is OH present in a hydrocarbon, that means we are talking about alcohol. So it says compound in which OH group is attached to an aliphatic carbon. Aliphatic carbon means single chain or straight chain hydrocarbons. And then it has a general formula of ROH. What is R in here? R is any alkyl group. So R can be any alkyl group like CH3, CH2, or R can be CH3, CH2, CH2, and then keep on going like this. So R is any alkyl group, carbon hydrogen compound. So now let's talk about phenol. What is phenol? Phenol has the same thing. It has a OH group. So whenever any benzene ring, this is a benzene. If I remove one of the hydrogen from the benzene and replace that hydrogen with an OH, then this entire compound become phenol. So phenol is benzene plus alcoholic group, which is OH group. The third functional group is ether. What is ether? So how are you going to figure it out? What functional group? How does the functional group looks like? So ether, you will always see a compound that has an oxygen atom between 2 carbon atom. So if you see any kind of this functional group COC, that means this is an ether group. For example, if I have CH, H, H, and then we have CH, H, and H. This is an ethane molecule, but if I put an oxygen in between, now it become an ether. This is the structure of now an ether because of this COC bond. Right, and the general formula for an ether is ROR. What is R? R is an alkyl group. O, R dash. R dash is maybe similar to the first alkyl group or may have a different structure. That's why we have an R dash over here. So now let's talk about what are the rules, IUPAC rules we need to follow to name an alcohol. So the naming will be the same. All the rules will be the same that we have been listening or like using for to name any alkane, alkene, and alkyne. We are going to use the same naming system or same rules, except the first rule will be you have to give the priority to the alcoholic group. You have to give the lowest number to the alcoholic group because this is a functional group and you have to prefer this functional group and give the lowest number when you start counting the parent chain. So let's take the example from this. So you have So you have 6 carbon, 1, 2, 3, 4, 5, 6, and on the third carbon you have an OH group attached over here. So make sure you know this thing. You cannot start counting of any hydrocarbon that doesn't have any carbon in it. So OH group doesn't contain any carbon, right? This is an ONH, this is alcohol. So you cannot start counting from the OH. You cannot give 1 to the OH. So you have to make sure you know this difference. You always have to start counting from the carbons. So that's why we have to start counting 1, 2, 3, 4, 5 and 6. So in this case we are going to get our OH group is on the third location, right over here. But if I would have to start from the other end, from this end, 1, 2, 3, 4, 5, 6, our OH group, functional group, which we have to give the preference for, that group is going to come on number 4, which is greater than the number 3 that we already used from the other side counting. So we have to start counting from left to right. That's the correct way of counting. So I'm going to remove the top number. And then how you're going to name any alcohol. So remember, whenever you name, the ending of an alcohol molecule should be end with OL. That's why you have an alcohol, OL. So again, you have to give the location number 3. You have 6 carbon, that's why it's hexane. And then you have to write OL at the end because this is a alcoholic functional group. So what you need to do, you have to just drop the finally from any alkane molecule. So let's imagine if you wouldn't have this OH group over here, so what should be the name? Hexane, right? But because of the presence of this OH group, we are going to remove this E and then write OL and then write in front of the location of the alcoholic group. So 3-hexanol. Okay. Let's try one more example which is already given over here. Again, we have to find the parent chain, and so that the OH group, the functional group, have to get, or you have to give the functional group the lowest number when you start counting the parent chain. So let's start from this side. 1, 2, 3, 4. If I go up, this is 5, but we are not going up because we already know we have 2 more carbon on the left hand side. That makes it up to 6. Similarly, if I when I was counting 1, 2, I wouldn't gone to this, because if I would have gone over here, there's only 3 carbon, right? So that's why we have to go all the way straight, so that parent chain will have 6 carbon, the maximum number of carbon. And you already included in this counting, you already included the OH group. The carbon that contain the OH group is already in the parent chain. So don't get confused. Is it not possible to include the OH group in your parent chain? Why? Because OH doesn't contain any carbon, and then you cannot count that OH group in your parent chain. But you have to include that carbon that has the functional group attached in your parent chain. So number 3 is the carbon that has the OH group, so you have that carbon already in your parent chain. So this is important. So make sure you don't do mistake or think about that OH is not in your parent chain. Okay, so now you have 3 substituent over here. This is 1 methyl group, second methyl group, and this is your main functional group. Right? So how we name them? So you always have to write alphabetically, right? We already learned about this thing. So on second carbon and on the 4th carbon, you have methyl group attached. So that's why you have to write 2,4 dimethyl. And then you have how many carbon? You have 6 carbon. That's why hexane. But because you have a functional group OH, alcoholic group, you have to write hexanol, and you have to specify on which location this alcoholic group is present. So that's why the name will be 2,4 dimethyl 3-hexanol. Right. So this is how you name any alcoholic group or any alcoholic containing hydrocarbons. So let's try to solve a couple of more examples how to name any alcoholic hydrocarbon. So this is our one of the hydrocarbon that contain OH group. So how are we going to name this molecule? So again, how many carbon you have in this molecule? You have one carbon here, one carbon here. So you have just two carbons. So the maximum that you have is 2. So which end you have to start counting? From this carbon or from this carbon? You have to think about this, which carbon you have to start counting so that the OH group will get the lowest number. So the carbon that has the OH group should get the lowest number. So you have to start counting from this carbon. 1, 2. Because the OH group is attached on this carbon. So you have to give the preference to the carbon that has the functional group. So you have two carbon is ethane, and then instead of writing ethane altogether, we have to remove E and put OL at the end. So this molecule is ethanol. You can write 1 ethanol because you are specifying the OH group is present on the first carbon. So even though if you are not writing that 1, it still is okay. So this is 1 ethanol or just ethanol. That will be your name for this molecule. Let's try another molecule. This is OH group over here. So how are we going to solve this problem over here? So first you have to make sure you find the parent chain, the maximum number of carbon in your parent chain, but you cannot skip the carbon that has the OH group attached to it because that's our functional group. So you have to include the carbon that is attached to the functional group. So this is the carbon that is attached, right? So you have to give the preference to this carbon 1 and then if you go up to, now you have a choice, either you can go left or you can go right. So I can see over here, if I go left, I have just 2 more carbon over here, 2 and 3. So I'm not going over here because I already seeing over here that we have more than 2 carbon on the right hand side. So I'm going over here 3, 4, 5. So the parent chain will be this 1, 2, 3, 4, 5, and this will be your substituent. This is your functional group. This is alcoholic group. So how are we going to name this molecule? So I can write 2. The first substituent is what? 2 carbon. This is ethyl. Right, 2 carbon is eth because this is substituent. That's why I'm writing ethyl, YL. So this is ethyl. So this is 2 ethyl. And then how many carbon you have in your parent chain? 5. 5 is pentane, and because you have an alcohol, that's why you have to write OL, pentanol, right? You can specify 2 ethyl, 1 pentanol, but because the OH group is present on the first carbon, we are not writing 1 in front of pentanol. So but if an alcohol is present on any other carbon except the first, you have to specify the location of the alcoholic molecule or group. So let's try one more example. This is OH. Or let's remove this one from here. Put this one over here, OH. Put CS3 or put one molecule over here. So try to name this molecule. How are we going to name this molecule? So you have to again start from the carbon. You have to give the lowest position to the carbon that has the OH group. So we have to start from this end, that's why we can get the second number on this carbon, the lowest number. Then we go 3, 4, 5. Now I can go up or I can go down. That doesn't matter because each of one has just only 1 carbon. So if I go down, this is 6. Always pick a straight one. This is your parent chain, the longest chain possible for any molecule, and then this is your substituent. So the naming will be 5 methyl because this is methyl, right? 5-methyl, you have 6 is hexanol, hexane, and then because you have an alcoholic group, hexanol. But what's wrong with this naming? Because the alcoholic group is present on the second carbon, we have to specify the location. So I can write 2-hexanol, 5-methyl 2-hexanol, or you can write the same thing like this too, 5-methyl hexane 2-ol, because you are specifying that the alcoholic group is present on the second carbon of the parent chain, right? So both the names are correct. Okay, so make sure you practice how to name any alcohol molecule, or practice the same molecule again, so that you know how to name this alcoholic molecule. So let's next slide. Now we are going to see how to name a phenol. how to name any phenol, and we already know what is phenol. Phenol is a benzene ring and you have an OH group attached to it. So this is phenol, benzene plus alcoholic group. So this is your phenol. So whenever you have any substituent attached on the phenol, your name will be derivative of the parent compound, which is phenol. For example, you have a bromine atom attached as a substituent, and we know this entire thing is phenol, right? And then if I'm using this as the main functional group, I have to give this carbon as our first carbon preference, 1, then 2, 3, 4, 5, 6. If I would have gone the other way around, it's not going to matter, because the functional group bromine is on the 4th carbon. So either you go clockwise or counterclockwise, it doesn't matter. The bromine atom is gonna get the 4th number or 4th location. So the name will be 4-bromo and then the parent chain. That's your parent chain, which is phenol. So it's 4-bromophenol. So let's try to name this molecule. The time you see benzene ring and alcohol group, I can say this is a parent chain, phenol, parent chain. So always look for this kind of indication where you have benzene, OH, benzene with some other name, with some other functional group that has a common name, right? Okay, so this is your parent chain. Now you have to start counting. You have to give the preference to this carbon 1 because it has the OH group attached, right? 1. Now which way you have to start counting, clockwise or counterclockwise? So it doesn't matter, because if I go over here too, you have the second functional group or second substituent. If I would have gone on this side, we have the second substituent on the second carbon, first substituent on the second carbon, so it doesn't make a difference. So let's go clockwise. This is 3, this is 4, this is 5, and this is 6 now. So the naming will be 2, 4, 6 tri-bromo. Why tri? Because you have 3 bromo attached to the phenol group, and then the parent name, right? So this is parent chain name, this is substituent, and these are the location of the substituent, right? So it is 2,4,6 tri-bromo. So now let's try to name couple of alcohol molecules, see if we can answer these problems. The first one is, we already done this thing. This is one carbon is methane, and then this is alcoholic group, so the name will be methanol, M-E, methanol, right? So we already done. What about the second one? So for the second one, we have to start counting from this carbon because it has the OH group, right? So make sure you have to give the preference to the OH group, but you also have to make sure the carbon that contain the OH group shouldn't be at the center of the chain of the hydrocarbon, because this carbon is at the end. It doesn't have any more carbon attached to it. That's why I'm writing this carbon as our first carbon, because you always have to start counting from the corners carbon, not from the middle of the carbon chain, right? So this is 1, this is 2. I won't go this way because we have just 2 carbon, and we know we have more than 2 carbon on the left hand side. So it's 3, 4, 5. So this will be my parent chain. We have 5 carbon. This will be our substituent. So the name will be 2, and you have 2 carbon substituent, which is ethyl, 2 ethyl. Then you have 5 carbon in your parent chain, pentane, and because you have an alcohol, instead of pentane you write pentanol. So 2 ethyl pentanol, or you can write 2 ethyl 1 pentanol, right? Both the namings are correct, right? Okay, so let's try to do some more example of naming of alcohol, especially phenol or any alcohol, any cyclic compound that has the OH group, alcoholic group attached. So let's try the first one. So you have this molecule, then you have this OH group, then you have CS3 group attached. So we have to write the name, how to name this molecule. So how are we going to name this molecule? The first thing that you have to know that this is not benzene. This thing is not benzene, because if you don't figure it out whether this is a benzene or not, if you would have figured out this is benzene and then you have a OH group, so you would have done a mistake of writing phenol to this molecule. But why is this is not benzene? It doesn't have any circle or alternate double bond within this cyclic hexane ring, right? So this is not benzene. So, and then because if it's not benzene, this is not phenol. So I'm going to remove everything. So make sure you don't do this mistake. See it carefully. So now how are we going to name this molecule? So you have to give the preference to this. This is cyclo compound, right? And you have an OH group. This is a functional group. The time you see a functional group, you have to give the preference to the carbon that has the functional group, right? So this is 1. Now you have to see whether you go up and start counting or whether you go down and start counting. So you have to pick. So we have to go down. Why? Because you have another substituent attached to this cyclohexane ring, right? So you have to start 2, 3, 4, 5, 6, because after you already given the preference to the functional group carbon, you have to give the preference to the other substituent. So what should be the name? I can write 3-methyl, and then this is cyclo, because this is a cyclic ring. We have to write cyclo. How many carbon you have in this ring? 6. 6 is hexane, but we are not going to write hexane because you have an alcoholic group in here, so we have to write hexanol. So 3-methyl cyclohexanol is the name for this hydrocarbon, or this cyclic carbon hydrocarbon. So let's do one more example on this. This is also cyclic hydrocarbon, and you have OH group attached to it. What should be the name for this molecule? So the time I see you have an OH group, I know this is as an alcoholic compound, and you have to give the preference to this carbon that has the alcoholic group. So 1, 2, 3, 4. So 4 is butane. So you have to write cyclo, because this is a cyclic compound. How many carbon you have in there? 4. 4 is butane, and then you have an alcoholic group. So butanol, cyclobutanol. Let's try one more. You have an OH group, you have chlorine, you have a methyl group in here. So how are we going to name this one? So the time I see we have a OH group, I know this is an alcoholic compound. So we have to give the preference over here 1. Now you have to give, this is methyl group, substituent, this is chloro group, right? So you have to start giving the substituent the next preference. So you have to write 2, 3, 4, 5, and you have to write alphabetically. So we are going to write 3 chloro, not 2 methyl, because C comes before M, so you have to write alphabetically. Then 2 methyl, and then we have cyclo, because this is a cyclic compound, 5-member ring, 5 is pentane. Because this is alcohol, so I have to write end word with OL. So it's 3 chloro 2 methyl cyclopentanol. So make sure you don't forget to write cyclo in front of the compound. Right. So make sure you practice all this compound too. So let's do a couple of more examples. So what should be the name for this compound? Now what's the difference from the previous example and with this example? We know this is benzene, and the time I see over here we have OH group, that is benzene plus OH group. We know this entire thing is phenol, because this is a benzene ring, not any cycloalkane. So that's why this is phenol. So once we figure it out, this is phenol, we have to just start counting the number. Give the preference to this 1, then 2, 3, 4, 5, 6, and then we can write 2 chloro, 3 fluoro, and then you have phenol as your parent chain. Right? Okay. So make sure you practice all this problem that we just did. So now let's go to the next topic, which is a primary, secondary and tertiary alcohol. So alcohol can be of different type depending on where the OH group is attached, or how many carbon is attached to the carbon that has the OH group. So we'll see what is meant by primary, secondary and tertiary alcohol mean. So primary alcohol means the carbon that has the OH group is just attached to one more carbon. So R group can be any alkyl group. R can be CS3 group, or R can be CS3 CS2 group. Right, this is an alkyl group. So primary alcohol is that alcohol in which the carbon that has the OH group attached is just attached to one more carbon. For example, over here, so this carbon has the OH group attached to it, and this carbon is just attached to one more carbon. So that's why this is primary alcohol. Whereas in secondary alcohol, the carbon that has the OH group is attached to two more carbon. So this can be carbon, this can be carbon, right? So this is secondary alcohol. For example, this carbon that has the OH group attached, this carbon also attached to two more carbon, this carbon and this carbon. So that's why this is a secondary alcohol. In tertiary alcohol, exactly the same thing. The carbon that contain the OH group is going to attach with 3 more carbon. 1 carbon, 2, 3 carbon. So that's why this is a tertiary alcohol. For example, the carbon that has the OH group is attached to 3 more carbon. Right? So that's why it's called tertiary alcohol. Right. And then we already know how to name it. This is 1 propanol, this is 2 propanol. Why? Because you cannot start counting from this carbon that has the OH, because this carbon is in the middle of these 3 carbons. So you have to start either from here, 1, 2, 3. So if you remember, I already told you cannot start counting the carbon that has the OH group from the middle. That carbon has to be at the end of the hydrocarbon, but this is not. What about this? What's the name of this molecule? So now this is the carbon that has an OH group, but this carbon is in the middle of all other carbon. So this is not at the ending of the carbon. So that's why we are not going to start this carbon as 1 by naming this carbon as number 1 carbon. So you have this free end, this free carbon, this free carbon. So you can start from either of these 3 carbons. So let's start with this carbon. 1, 2. I can go left or I can go straight down. So I'm going to go straight down. So this is your parent chain, and on the second you have alcohol, and on the second you have methyl group as your substituent. So that's why it's 2-methyl 2-propanol, means 3 carbon is propane. On the propane parent chain, on the second carbon you have an alcohol. That's why you have to specify the alcohol name. And then also on the second you have methyl group. That's why this is 2-methyl 2-propanol. So this is also helpful to know how to name the molecule. But make sure you know the difference between how to figure it out whether the alcohol is primary, secondary, and tertiary. Let's do a couple of more examples to figure it out how to differentiate between primary, secondary, and tertiary alcohol. So let me give you one example. This is the OH group. So this is the one. Second example is this is OH. And the third example is OH. So out of the 3 molecules, you have to differentiate the alcohol is primary, secondary, or tertiary. So let's start with the first one. So this is the carbon that has the OH group, right? And this carbon is attached to how many carbon? Just 1 more, right? Other are hydrogen only, right? So this is primary alcohol, or you can write primary. So let's try to do the second one. This is the carbon that has the OH group attached. How many carbons are attached to this carbon? So this is the one of the carbon that is attached to this carbon, and then 1 more carbon is attached to the carbon. So that means this carbon is attached to 2 more carbon. So this is secondary alcohol. Secondary alcohol. So now let's try to do the third one. So how are you going to do it? So this is the carbon that has the OH group, and how many carbon attached to this carbon? 1 and 2. 2 carbons are attached. So this is also a secondary alcohol or secondary alcohol. Okay. So let me give you one more, fourth example. Right. So what do you think about this molecule? This alcohol is a primary, secondary, or tertiary? So let's figure it out. So this is the carbon that has the OH group attached, and you have to see how many carbons are attached to this carbon. So this carbon is attached to this carbon, this carbon is attached to this carbon, and this carbon is attached to this carbon. So you have 3 carbon attached to the carbon that has the OH group, OH functional group. So that's why this is a tertiary alcohol. Tertiary. So this is very important. Make sure you practice how to figure it out primary, secondary, and tertiary alcohol, because we need this information to carry out couple of chemical reaction of alcohol. So if you cannot figure it out whether the alcohol is primary, secondary, or tertiary alcohol, it might be a difficult task for you to carry out some of the chemical reaction of alcohol. So now let's talk about the physical property of alcohol. What are the physical property? So the first one is solubility of alcohol in water. So the smaller alcohols are soluble in water, means from alcohol containing carbon from 2 to 5 carbons alcohol are soluble in water. And how they're going to get soluble in water? So let's see, because they form hydrogen bonding with water molecule. So if any compound or any molecule can form hydrogen bond with the water molecule, means they are soluble in water. And because OH group, which is an alcoholic group, this is a polar group, right? So polar group can form hydrogen bond, right? So let's try to understand how the alcoholic molecule can form a hydrogen bond with water. So this is water. If you see carefully, this is H2O, OHH. This is H2O, right? And then the second one, this one is your alcohol, CH3OH. This is methanol. So so remember this thing, if your hydrogen is attached with fluorine, oxygen, or nitrogen, these 3 atoms, if these atoms are attached with the hydrogen, they can form hydrogen bond with some other atom, right? So let's take the same example over here. So this oxygen has hydrogen atom attached to it. So this is the condition that is met over here. And from water, you have oxygen and hydrogen bond. You have 2 oxygen hydrogen bond. So that means the hydrogen is available to form hydrogen bond. So how they're going to form? You have another water molecule over here. The hydrogen from the methanol is going to make a hydrogen bond with the oxygen of the water through this bond. This is your hydrogen bond. Because hydrogen bond is also always formed between fluorine, oxygen, and nitrogen. Similarly, if you go over here, the hydrogen from water is going to make a hydrogen bond with the oxygen of the alcohol molecule. If you see, this is alcohol OH, but the hydrogen from the water molecule is making a hydrogen bond with oxygen. This is again the second condition. So this is bond, this is a hydrogen bond. So because of formation of these hydrogen bond, alcohols are soluble in water. They can easily miscible with the water. But the thing is that only low molecular weight alcohols are highly soluble in water. Why? So let's remove this one. So let's say this is one of the alcohol. This is OH, right? This is second alcohol. This is third alcohol. And I can have many carbon alcohol, right? So if you have less number of carbon in your alcohol, 1, 2, 3, 4, 5, this OH group can help the alcoholic molecule to get dissolved in water. But as the number of carbon chain is getting increased, So what's the effect of higher number of carbon atoms if it's present on your alcohol molecule? What was the purpose? Because this chain is hydrophobic. Higher the number of carbon atom in the chain means you have high hydrophobic molecule present in the alcohol, and this one alcoholic group is not able to dissolve the long chain of carbon, which is hydrophobic, means this chain cannot dissolve in water. So if the number of chain is small, if you have less number of carbon present in the molecule, this OH group can help this non-polar carbon to get dissolved in water. But as the number of carbon chain is getting increased, the efficiency of this OH group is not as great as it was before, when the carbon atoms were just 2 or 3 or 4. Right? So that's why low molecular weight alcohols are soluble in nature, while the high molecular weight or high number of carbon atom present in the alcohol is not soluble. The second property is and like I already told you in this slide, larger alkane have greater hydrophobic region and are less soluble in water. If you can see, these are hydrophobic region. Right? They are not soluble in water. So if you have just one OH group attached with this large part of the hydrophobic region, then this one OH group is not able to just accumulate all the hydrophobic region within the water molecule to help this large agent to get dissolved in water. So now let's talk about the second physical property. The OH group can make a hydrogen bond between alcohol molecule with that lead to a high boiling point. So our next property is high boiling point. So how does the alcohol has the higher boiling point compared to the alkene? So if I say alcohol has higher boiling point than alkane. Why? Because of the hydrogen bond. They are going to form a hydrogen bond between the alcohol molecule, and they bind strongly so that you need more energy to break that bond. So that's why the boiling point of alcohol is much higher. So let's take this example. This is one alcohol. This is ethanol. This is again ethanol. You have 3 carbon. No, this is again ethanol. So you have 3 ethanol molecule in this structure, and then if you can see this O, the hydrogen attached with the oxygen atom of the alcohol, can form a hydrogen bond with the another oxygen from another alcohol. Right? So this is your hydrogen bond. Right? And then the hydrogen from the second alcoholic group, can form a hydrogen bond with the third alcoholic oxygen. Right? So this is also hydrogen bond. If I put one more ethanol in here, CH3, CH2, OH, this is another ethanol molecule. Then they can form a hydrogen bond. Because this hydrogen is attached with the oxygen. And if you remember, I told you that if hydrogen is attached to the oxygen, this hydrogen can form a hydrogen bond. Right? So this hydrogen is attached to this oxygen, and then the hydrogen can form a hydrogen bond with one other oxygen from another molecule. So because of these hydrogen bonding, the boiling point of the alcohol molecules are more compared to the alkane with the same number of carbon atom. So for example, if I have ethanol, and if I have ethane, This is alkane, this is alcohol. So the boiling point of ethanol is always bigger than similar containing carbon called ethane because of the hydrogen bond. So make sure you know this property of making of hydrogen bond by the alcoholic molecules. So now we're going to talk about certain chemical properties of the alcoholic molecule or chemical reaction performed by alcoholic molecules. So there are many chemical reactions that can be shown by alcohol, but in this lecture we're going to just talk about only two chemical reactions that we are mainly interested in. One is called dehydration reaction. Second one is called oxidation. So we are going to just study about these two chemical reactions given by the alcoholic molecule, which is dehydration and oxidation. So first we are going to talk about the dehydration part first. So what is dehydration reaction? Dehydration, as the name is saying, dehydration means removal of water. Removal of water from the molecule. So whenever you remove water after doing that chemical reaction, that means you are dehydrating the chemical. Right? It depends on the reaction mixture. This reaction is normally depend on the temperature, at which temperature you are taking out this reaction. At 140 degrees Celsius, your product will be an ether. And if you remember, ether is COC, right? Oxygen between two carbon. But if you perform the same dehydration reaction at 180 degrees Celsius temperature, product will be different than ether. Then the product will be an alkene. So remember, this is very important. You always have to keep in mind at what temperature you are doing the dehydration reaction. Whether you are doing at 140 degrees Celsius, then the product will be an ether. But if you are doing at 180 degrees Celsius, your product will be changed, and then the new product will be an alkene. Right? And this kind of dehydration reaction is normally called as elimination reaction. Why? Because you are removing it, breaking the bond and removing the molecule. So you are eliminating some of the atom from the chemical reaction. So let's try see some example. So this is an alcohol. You have carbon, carbon. The time you see this OH group, you know this is an alcohol. And this reaction is performing in the presence of an catalyst, which is sulfuric acid, H2SO4, or an acid, at temperature 180 degrees Celsius. And if you remember from the previous slide, I told you that if you're doing the dehydration reaction at 180 degrees Celsius, you're gonna make an alkene with a double bond, right? And then you are removing water as a byproduct. So how does this reaction happens? Let's take an example, a specific example. So this is 2-propanol. This reaction is going on in the presence of an acid at 180 degrees Celsius. So what you're going to do, so you have to take an OH and then the hydrogen from the corresponding carbon or the nearby carbon. So this is the carbon that has the OH group, right? Then you have to either pick a hydrogen from this carbon, because this carbon is attached to the carbon that has the OH group, or this carbon. This is also attached to the carbon that has the OH group. So you always take a hydrogen from the carbon that is attached to the carbon that has OH group, and then remove as water. So OH from the molecule and hydrogen from the next carbon come close together, remove as a compound as water, H2O. And then if you are breaking this bond, what's going to happen if you break this bond? Now both the carbon has only 3 bond over here, so they tell each other, okay, we both has 3 bond, let's make one more bond, right? So that's why you're going to get a double bond in here, because carbon has to have 4 bond all the time. And because of the double bond, now your making an alkene, and the name of this alkene is 1,2,3 propene, 1 propane or just propane with water as your product, right? Okay, let's try another example. What's the name of this alcohol? 1, 2, 3, 4. This is 2-butanol, right? So now you have OH group, and this is the carbon that contain the OH group, right? Now you have to take out the hydrogen from the corresponding carbon or the next carbon that is attached to the carbon that has the OH group. So now you have 2 carbon that is attached directly to the carbon that has OH. One is this, another one is this, right? So what you can do, either out of the 3 hydrogen you can pick 1 hydrogen from here and then remove as water, right? So or second, if you're going to remove the one of the hydrogen from this carbon, then what's going to happen? You're removing this as water, and then you're going to make a double bond between 2 and 1, right? Because you're taking a hydrogen from the first carbon and remove as water. So this is the product that you're going to make, right? So this is one way, but let's imagine if you wouldn't have taken the hydrogen from the first carbon. Instead of first carbon, if you would have taken the hydrogen from the third carbon, so what should be a product? If I have to take the hydrogen from out of the 2, if I'm taking this hydrogen, then H plus OH, now remove as water again, but now the double bond is gonna come between what? 2 and 3, because you remove the hydrogen from the third carbon. So now this will be a product, right? 1, 2, 3 and 4. So now so these 2 products can be possible, because it's up to you whether which hydrogen you're going to use. If you're using the first hydrogen, this is your product. If you're removing this hydrogen from the third carbon, this is your product. So always remember this will be our major product in here. This is the product that's going to be producing in high number or high amount. Why? Because this product is stable. So this alkene is an stable alkene. So how are you going to figure it out which alkene is stable? So let me write over here how to figure it out, the stable alkene. Okay, so I can write more substituted alkene is the stable alkene. What is more substituted mean? So the carbon that has the alkene, let's say the alkene is between these 2 carbon. If this carbon is attached to another carbon, that means this alkene is more substituted compared to the same alkene that is attached to this hydrogen and hydrogen. So you have to look how many carbon is attached to the carbons that has the alkene functional group, right? So this carbon, these 2 carbon that has the double bond or alkene group is attached to just hydrogen. There is no more hydrogen, there is no more carbon attached to these 2 carbons. So this is less substituted. But in the second picture or second molecule that I drew over here, you can see the carbon that has the double bond is attached. One of the carbon is attached to 2 carbon. So this is more stable than the first one, right? Because this is more substituted, more carbon is attached. And if I draw the another molecule, same thing, C double bond C, now you have carbon attached to both of the carbon that has the double bond. So now you have more substitution, right? So this is the most stable alkene, because the 2 carbon that has the alkene has the carbon attached to them directly, right? So let's compare the same concept over here. So this carbon that has the alkene functional group is attached to how many carbon? This carbon attached to this carbon. This carbon is attached to this carbon, right? So both of them has at least one carbon directly attached to the carbon that has alkene group. Over here, so this carbon is still attached to one of the carbon, but this carbon is not attaching with any of the carbon. It has just hydrogen, means it has just two hydrogen attached to it, right? So this is less substituted compared to the first product. So that's why this is our main product. This will be your main product when you do a dehydration reaction at 180 degrees Celsius for this alcoholic molecule, right? So you will always see a major product in your problem in your multiple choice question, or if I ask you to draw the product, you always have to draw the more substituted alkene or more stable alkene, right? If you can say this is 90%, right? Okay, so let's try to do some more examples so that you understand how to take out or how to dehydrate any alcohol and to get the stable alkene as your main product. So let's take one example. Let's say this is your cyclopentane, and then if you put any alcohol molecule in there, now this is cyclopentanol. And if I have, and then let's say you have one CH3 group over here. So if I have to do dehydration reaction for this molecule in the presence of an acid, make sure you remember the catalyst H2SO4 in the presence of 180 degrees Celsius temperature. What should be my product? We know this is a dehydration reaction, right? Because we are doing it 180. So we have to just look for how to get the product. So let's see, we have this carbon that has an OH group attached, right? And this is the carbon that is next to the carbon that has OH, and this is the next carbon, right? So even though we cannot see a hydrogen in this carbon, but we have two hydrogen in here, right? Because carbon has to have 4 bonds. So in line angle formula we usually don't show, but for this particular reaction we are showing that it has 2 hydrogen, and this carbon how many hydrogen attached to this bottom carbon? So this carbon already has 3 bonds, that means it has just 1 hydrogen attached to it because it already have 4 bonds. So now the question is, which hydrogen you have to take out of 1 and 2 carbon? Which hydrogen you have to pick out? The hydrogen from the first carbon or hydrogen from the second carbon to dehydrate this molecule? So let's imagine, or let's assume we are taking out this hydrogen from the carbon number 1 and remove this as water. So this is water. So if I removing the hydrogen from the first, then the double bond is gonna come between these 2 molecules. So let me draw the molecule again. So the double bond is gonna come between this molecule 1 and the carbon that has the OH group, right? Because you took this thing. So this might be one of the product. What can be your second product? So instead of the hydrogen from the first carbon, if you would have taken the hydrogen from the second carbon, so now you are taking this hydrogen and remove as water again. So your product will be this. The double bond is gonna come between second carbon and the carbon that had OH group, right? So now you have to think out of the 2 product that you made, depending on which hydrogen that you took to make it water with the hydroxyl group, with the OH group, This is product A, this is product B. Which product is gonna be a major product or main product? So like I already told you, the more substituted alkene is the major product always. So let's go to the product number A and see whether this alkene is more substituted or not. So this 2 carbon has the double bond, and this carbon is attached to what? Just 1 carbon, right? And this carbon is attached to 1 carbon. So both the carbon that has a double bond is attached to just one more carbon, right? Whereas in this B structure, these 2 carbon that has a double bond, let's see how many carbon is attached to each of them. So the carbon is attached to 1 more carbon, and this carbon is attached to this carbon, and this carbon is also attached to this carbon. So this means this carbon has 2 carbon attached to it, and this carbon has 1 carbon attached to it, right? Whereas in part A, you have just one carbon attached to the carbon that has a double bond. So this means this is more substituted alkane. So this will be our major product. So if I give you this problem, you have to show me then this is the main product that you're gonna form. So let me again make a diagram, main product, if you don't get confused. So the product will be this. And what's the name of this alkene? So let's try to name first this alcohol. This is cyclopentanol, right? Because you have alcohol and this is a cyclic ring. And what's the major product name? You have to give the preference to the double bond. So you have to pick 1, 2, 3, 4, 5. And what should be the name? This is 1-methyl cyclopentene, because the double bond is present on the first carbon. So this is the name. So that means you are converting alcohol to an alkene, right? So this is not our major product. So let's try to do one more example on this. This is OH, this is methyl group, and if I do the same thing again in the presence of H2SO4 at 180 degrees Celsius, what will be our major product? So this is an OH. We have to see which carbon has the hydrogen bond. So the next carbon has 2 hydrogen, and this carbon, the carbon attached to the carbon that has OH group, has 1 hydrogen. So if you pick, let's number it, 1, 2, 3, 4, 5, 6. If you pick a hydrogen from the third carbon, then you're gonna have a bond between 4 and 3, right? So your product will be something like this. This is your product A. If you would have taken the hydrogen from the 5th carbon, then your product will be like this. An alkene is going to come between 5 and 6, 4 and 5. So which one out of the 2 product, which one is the major product? So the more substituted alkene is major. So this carbon that has the double bond is attached to 2 more carbon. This carbon attached to 1. So similarly from the bottom, this carbon attached to just 1, and this carbon just attached to 1. So this is more substituted alkene because this carbon is attached to 2 carbon, right? So this will be our major product, right? And what's the name of the reactant that we use to do this reaction? This is 3-methyl 4-hexanol, right? Because you have 6 carbon. And what's the name of the major product? So it's gonna be 3-methyl 3-hexene, because the double bond is present on the 3rd carbon, right? So, and this is not our major product. This is just a small product that you can make, but this is our major product. Okay, so now let's go to the second reaction called of dehydration reaction, but the only difference is now the temperature is 140 degrees Celsius, not 180. So that's the difference. So in this reaction, 2 alcohol molecule combine together or mix together. So that's the difference. In the previous dehydration reaction at 180 degrees Celsius, you are just using one single molecule of alcohol. But in this type of dehydration reaction at 140 degrees Celsius, you have to have at least 2 alcohol molecules mixed together. So what's going to happen? When the alcoholic molecule comes close together, OH from one of the alcoholic and hydrogen from the another alcoholic molecule come close together and remove as water, H2O. And then what's else left? The other thing left is R and OR. So that's why you're gonna get this product, ROR. So once the water is removed, everything gets stuck up, then you're gonna get ROR as a product. And what is ROR? Is an ether, because R is any alkyl group, R is any alkyl group, and then this is an ether. So let's take an actual example over here. This is ethanol, this is also ethanol. Take this water, OH from one of the alcohol and hydrogen from another alcohol in the presence of H2SO4 at 140 degrees Celsius. Now you're gonna take out this as water, and then everything else is gonna stuck together. CH3, CH2, CH3, CH2, and then oxygen at the center. Then this is your ether. So remember this difference between 180 degrees Celsius dehydration and 140 degrees Celsius dehydration means. Now let's talk about the oxidation reaction given by the alcoholic molecule. So what is oxidation? Oxidation is a process where a molecule, or especially in this case alcohol, loses hydrogen atom or gain oxygen atom. So if any molecule is gaining and one extra oxygen, means they're getting oxidized, and if they're losing hydrogen, that means it still means that they're oxidized, they're getting oxidation reaction. And then alcohol oxidation reaction always perform in the presence of an oxidizing agent. So what is oxidizing agent? Oxidizing agent are that molecule that helps the alcohol to do the oxidation reaction. The two main oxidizing agent is K2Cr2O7 and KMnO4, potassium dichromate and potassium permanganate solution. So how does this process occur? Let's say you have any alcohol molecule. This is alcoholic group OH, this is carbon, this is one of the hydrogen attached to the carbon, and then this is the oxidizing agent. This is the symbol O. Whenever you see this symbol, that means you are doing oxidation reaction. Oxygen with a bracket, right, with a parenthesis. So what happened when you oxidize, the hydrogen along with oxygen remove as water, and then once the bond is getting break, carbon and oxygen will say to each other, okay, you also need one bond, I also needed one bond, because hydrogen is also left from my side. Let's make one extra bond. So now you're going to make a double bond instead of a single bond. And then this group, C double bond O group, has a special meaning. This is called carbonyl group. You're going to learn in the next chapter. This is a carbonyl group. And where we can find carbonyl group, whether it's an aldehyde or ketone. We're going to discuss in the next class what is aldehyde and ketone, but right now just make sure that you know if you have C double bond O structure, this may be either aldehyde or ketone, and this can be H or R. So we'll learn about all this thing, but just right now, whenever alcohol oxidize, it form aldehyde or ketone. That's the main thing. So now we have to see how these different classes of alcohol perform in the presence of an oxidation reaction. We already know how many classes of alcohol we have. We have 3: primary, secondary, or tertiary alcohol, and we already know how to figure it out whether the alcohol is primary, secondary, or tertiary. So let's start with the primary alcohol and how does it behave in the presence of an oxidation reaction. So whenever you do an oxidation reaction for primary alcohol, it convert into an aldehyde, and then it don't stop in this product, because oxidation is oxidizing agent or oxidation reaction is so strong, conditions are so strong, you won't get an aldehyde, but aldehyde is going to convert into a carboxylic acid. So if somebody asks you what will happen if you do a oxidation for primary alcohol, you will get a carboxylic as your main product. This is your main product, and aldehyde is the product that form in between, right? And it's not stable, and then it's going to convert into a carboxylic acid. So let's take an example. This is primary alcohol, because we already know this is primary alcohol. When we do an oxidation reaction in the presence of oxidizing agent, what's going to happen? Water is going to remove, and then you will get a double bond over here, right? And this is an aldehyde. So what is aldehyde? So I'm going to discuss briefly over here what the structure aldehyde looks like. So we know this is a carbonyl group, right? On this carbon you have, so carbon have to have 4 bond, right? So 2 bond is already with the oxygen and the other 2 bond. So if out of the 2 bond, if one of the bond is attached with the carbon or any alkyl group, R group, and that the other bond is with the hydrogen, then this is an aldehyde. So in aldehyde molecule, one of the bond of the carbonyl group is attached with the hydrogen, another one with an carbon or any alkyl group, right? Whereas in ketone, so this is an aldehyde. So let's talk about ketone. What is ketone? So ketone also has a functional group, C double bond O, carbonyl group, and carbon has 4 bond. So in ketone, the carbonyl group, both the bond of the carbonyl group is attached with the R group, so that there is no hydrogen attached directly to the carbon that has the carbonyl group, right? So you have RR group on both sides. So if you see anything like this, C double bond O C, that means this is ketone. If you see something like this, C double bond O H, this is aldehyde, right? So till now just remember this small concept so that you know whether you're going to make an aldehyde or ketone. Then we will discuss this functional group later on in the next chapters. Okay, so let's talk about this over here. So this is an aldehyde that's going to form from the primary alcohol after getting oxidized, and then I already told you it's not stop over here, it's going to oxidize one more time, and then you're going to make a carboxylic acid, and this is the group, carboxylic acid group. Functional group. So what's the difference? With carbonyl group, you have an hydroxyl OH group attached to the carbonyl group. So that's why this is carboxylic acid group. Right. Okay. Now let's talk about the secondary alcohol. Secondary alcohol, when you oxidize secondary alcohol, you always going to get a ketone. And what is ketone? R, C double bond O, R. Right? R can be carbon. Right? So let's see. This is secondary alcohol. This is secondary carbon. Secondary alcohol, when you oxidize it, what you're gonna get? You're gonna get C double bond O after you remove water. Right? And if you see on the carbonyl group, you have on both sides carbon attached. So that's why this is a ketone. Right? So you have to remember, primary alcohol gives you a carboxylic acid or aldehyde. Secondary alcohol will give you a ketone. And the tertiary alcohol won't do anything with the oxidation reaction. Means tertiary alcohol don't show any reaction. They don't react. So you have to remember this thing. If I give you any alcohol with a tertiary alcohol in it, any compound with a tertiary alcohol in it, and if I ask you what's the oxidation product, the answer will be no oxidation product, or no reaction, or no product is going to form through oxidation. Okay. So let's do a couple of examples of alcohol oxidation. So let's start with ethanol. Ethanol is what? Primary alcohol. This is primary alcohol. So we know if it's a primary alcohol, what we're gonna get? We're gonna get this OH is gonna remove, and one of the hydrogen is gonna remove from here, and then you're gonna get C double bond O. Right? Because this thing is will be like this: CS3, CS2, OH. So that's why you will have C double bond O, because OH is attached to the carbon. Right? So this is an aldehyde. Why? Because carbonyl group attached with the hydrogen directly. It goes further oxidation, you're gonna get acetic acid. So don't worry about the naming, how we name any carboxylic acid. You have to just know then this is a carboxylic acid group. Right? Let's do another example, 2-propanol. This is secondary alcohol. Secondary alcohol. So if this is secondary alcohol, what's gonna happen? You will get a double bond after removing the water. You will get this carbonyl group, and then across the carbonyl group you have two carbon attached directly to it. So this will be R, C double bond O, R type of structure, and so this is a ketone. So secondary alcohol always form a ketone. So let's try to solve a couple of more problems on the oxidation of an alcohol. This is your one. This is oxidation. This is oxidation. This is oxidation. Okay, so now let's try to solve these three problems and see what should be a product if we oxidize all these three compounds. So let's try to solve the first one. So in the first one we have an alcohol. When we oxidize, we need to know which type of alcohol is this one, primary, secondary, or tertiary. Depending on which type of alcohol we are working with, we can figure it out what should be our product. So let's say this is the carbon that has the OH group. So let's say this carbon is tertiary or secondary or primary. So this carbon that has the OH group attached to one carbon, two carbon, three carbon. So this is tertiary alcohol. This is tertiary alcohol. And we know if it is a tertiary alcohol, then there won't be any reaction through oxidation. So that means no reaction, right? Or no product. Right. So this will be our answer for the first one. What about the second one? We have to see which alcohol is this one. So this carbon that has the OH group attached to one carbon, two carbon. So that means this is secondary alcohol. So if you remember, secondary alcohol always form a ketone. So what is ketone? So I can make this compound C double bond O, right? So this is C. Why this is a ketone? Because this carbonyl group C double bond O, carbonyl group, is covered by on both sides by carbon. So C double bond O carbon. So it's gonna be like this. And this is a ketone, if you remember. So secondary alcohol form a ketone. Let's do the third one. Which type of alcohol is this one? This is primary alcohol. And if you have primary alcohol, if you oxidize, you know you're gonna make an aldehyde, if you remember. So let's try to make 4, and I can write double bond O, because this is the carbon that has OH group. So this the same carbon will get C double bond O, carbonyl group, right? And then we already know each carbon have to have 4 bond. So this is 2 bond with an oxygen, 1 bond with the carbon. So that means you have 1 bond with the hydrogen. So that's why this is an aldehyde. Aldehyde is always C double bond O and then hydrogen on one of the carbon that has the carbonyl group. So that means you have hydrogen, right? So that's why this is an aldehyde. So you're gonna have no reaction for the first one. You're gonna make a ketone, and then for the third one you're gonna make an aldehyde, right? So always make sure whenever you oxidation, make sure you know what type of alcohol you're dealing with, and then you should be able to understand what type of product you're gonna get, right? So make sure you practice all these type of problems. Okay, so now let's talk about some of the important alcohol that we normally use. The most common one is ethanol. This is also called ethyl alcohol. This is the structure, and is produced commercially from ethylene and through biological fermentation of the carbohydrate. Right. So what's the uses of this ethanol? Ethanol is used as a solvent in industry and sometimes used as a fuel. It also found in alcoholic beverages and is mildly toxic. So this ethanol is a toxic liquid. So some other alcohol are automobile antifreeze. So which kind of alcohol we use in the automotive antifreeze? This is ethylene glycol, which is 1,2-ethanediol. This is 1,2-ethanediol. So you have to just remember the name. If I ask you which alcohol normally we use in automotive antifreeze or as an antifreeze, you have to write ethylene glycol or 1,2,3-ethanediol. 2-propanol we use as a rubbing alcohol. So they are common alcohol that you have to just know the function or the uses of those alcohol. So now let's talk about Phenol. So we already talked about what is phenol is. Phenol is a benzene ring with an OH group on the top. That's your phenol, right? It is a colorless, low melting point solid with a medicinal compound, right? And we also use this as an antiseptic agent. Right, a small antiseptic liquid. So how does it what's the chemical property of the phenol? So if we put phenol is a weak acid, means if you dissolve phenol in water, hydrogen is going to remove and then goes to the water, right? And then you will get a product, right? Phenol also can react with a base to form a salt. So KOH is a potassium hydroxide. When you react with phenol, it react as a base. It react with the base, hydrogen go with the base. You're gonna get water, H2O, and you're gonna make a salt. So what is the uses of phenol? Phenol is normally used as disinfectant in dilute solution. You can also use in hospitals as a disinfectant, and they also can be used as antioxidants in food. They helps the food to not rotten faster. They normally used to preserve the food. Couple of examples are BHA and BST. So you have to just remember these two terms. They are antioxidant. We normally put in the food to preserve the food for a longer period of time. So now let's talk about another functional group called ether. And we know what is ether functional group, COC, when you have oxygen atom in between the carbon. So how we normally name an ether molecule? There are two ways to name an ether molecule. One is common name, another one is your IUPAC name. So we'll try to learn both of them together. So how to name a common name? So you have to see how many carbon is attached to the carbon or to the oxygen atom on each side of an oxygen atom. So in this case you have methyl group, so you just write dimethyl ether. So the ending word of an ether is always ether, right? This is your ending word. So if we have another example, let's say, what's the name of this compound that I drew just right now? So you have 1 2 1 2. So this is ethyl, this is ethyl, right? You have two carbon chain on across the oxygen. So I can write this as dimethyl, because you have, it's not dimethyl, it's diethyl. Diethyl, because you have two ethyl group, that's why it's diethyl. And then at the last you have to just write ether. So diethyl ether, right? So this is the common name how you usually write. So you have to just look how many alkyl group is attached and what's the number of carbon you have in that alkyl group, and you have to just name the alkyl group and put ether at the end. Okay, then let's try to learn the IUPAC name. How are you going to name an ether using an IUPAC nomenclature or the universal accepted name? So you have to pick, you have to pick the smaller chain alkyl group, and and you can name the smaller chain as alkoxy group, right? So again, same thing, you have to pick. So let's take an example over here. So this is the bond COC, right? This is an ether bond, right? So across the oxygen you have this one of this ethyl group attached. So you have this ethyl group attached, and on the other side of the oxygen you have this entire group of alkyl group attached. So you cannot start counting from this carbon, because this is at the center of the alkyl group, so you have to start counting from that corner carbon so that you get the lowest number to the carbon that has the ether group, the oxygen group attached to it. So this is 3, this is 4. So like I said, the smaller alkyl group we use as alkoxy, right? So this is ethyl, I can write ethoxy, right? And then you can just write the other alkyl group as your alkane molecule. So this is 2-ethoxy, because on the second carbon you have this ethoxy group attached. And then how many carbon you have in the parent chain? 1, 2, 3, 4. Butane, 2-ethoxy butane. So let's try to solve a couple of more examples so that you better understand how to name it. So let me give you one example over here. So what's the ionic name of this molecule? The time I see you have COC, that means this is an ether group. We confirm this thing, this is an ether, COC. So how to name the ionic name? You have to pick the alkyl group that has the smaller number of carbon atom in it. So this is the smaller number across this oxygen. You have just one carbon in here, right? On the second side, how many carbon atom you have? You have 1, 2, 3. You have 3. So the rule says you always have to use the smaller alkyl group and treat as an alkoxy group. So this is one carbon, this is methyl. So we can write, instead of methyl, we have to write methoxy. And then the other carbon chain we use as a normal alkane chain. So I can write 1, 2, 3 is propane. So I can write methoxy propane, right? So this is methoxy propane. Let me give you one more. So this is the compound that you have to name it. So the time I say COC, we know this is an ether group, and then you have two alkyl group. On one side you have this cyclopentane group, and on the other side you have just one carbon, which is methyl group. So how to name an ionic name? You have to always pick the smaller carbon chain as your alkoxy chain. So the name will be methoxy. And then this entire chain you can just write as an parent chain, common parent chain. So this is methoxycyclopentane. So this is the name, right? So this is cyclopentane. Cyclopentane. So the name will be methoxycyclopentane. So now let's talk about the properties of the ether. Ether are much less polar than alcohol. We're gonna see later on why this is the case. More soluble in water than hydrocarbons, but less soluble than alcohol. So that means the solubility of ether is greater than hydrocarbons. This is solubility in water, like alkane, alkene, alkyne, right? All these hydrocarbons, the solubility is more in water, but it's less soluble than alcohol. So that means I can say alcohol is more soluble in water compared to ether, but ether is more soluble in water compared with hydrocarbons. So this is a sequence of water solubility of different organic compound. So ether also has low boiling and melting point because its inability to form a hydrogen bond with other ether molecules. So that means ether molecule cannot make hydrogen bond with other ether molecule. And because of this inability to form a hydrogen bond, it has low melting and low boiling point compared with alcohol, right? Because alcohol can make a hydrogen bond, that's why they have more boiling and melting point, much higher. Ethers are inert and do not react with most reagent, so that means they doesn't show any chemical reactivity most probably, and they are highly flammable, right? So now let's talk about the property, the same property that we have discussed in the previous slide. The first one is if ether mix with water, whether they're gonna make a hydrogen bond or not. So like I said, this is water. Water has OH bond, and this hydrogen is attached with the oxygen. That's why it's available to make a hydrogen bond with any other atom like oxygen, nitrogen, and fluorine. So from the ether COC, you have an oxygen atom. So the water can form a hydrogen bond through its hydrogen with an oxygen atom of an ether through and form a hydrogen bond, right? So that's why ether can be dissolved in water, even though it's very slightly, but still you can dissolve ether in water because they can form hydrogen bond. The second property is there is no hydrogen bonding within the ether molecule. Means you have one, this is your first ether, this is your second ether, COC bond, right? So if you can see, there is no hydrogen available to make a hydrogen bond, right? So this is oxygen, but on this oxygen you don't have any hydrogen. Same thing with the another oxygen of the same different ether. You don't have any hydrogen. If you don't have any hydrogen, how you gonna make a hydrogen bond? So that means ether cannot form a hydrogen bond within themselves. That's why they have low melting point and low boiling point, because they don't have hydrogen bond, so they can easily be broken down by giving us a small amount of heat energy. So now let's go to the another functional group called thiol. Thiol is like an alcohol, but the only difference is here instead of OH we have SH. So what's the difference between thiol and alcohol in functional group wise? In alcohol we have OH, but in thiol we have SH. So O is getting replaced by S. Right? So this is an thiol group. Right? So what's the distinguished characteristic or property of thiol? They have strong offensive order, right? And there are a couple of thiol molecule that can be used in different ways, right? Ethane thiol normally used in natural gas, and there are some propane thiol used in order in onions. But let's see how we're going to name any thiol compound containing thiol. So again, the same principle, you have to give the preference to the thiol group first. So let's take this example. You have to start counting from this carbon 1 2 3. If I can go 4, I can go straight 4. So but I'm going to go straight. So this is your parent chain, and on the third carbon you have methyl group. So this is 3 methyl. How many carbon you have? You have 4 butane, but In alcohol you put ending word as ol. In thiol you're going to put an ending word as thiol. So 3-methyl 1-butane thiol. Right. Similarly, if I have something like this structure, SH, so you have to give the preference to the thiol group 1, 2, 3, 4, 5. Then you have to just write 3 pentane thiol. Means on the third carbon of this pentane molecule we have a thiol group attached. Right, so this is how you normally name any thiol compound, thiol containing compound. So there are a couple of reactions that is also given by a thiol group like we had for alcoholic group. So we're going to learn about what are those reactions that is given by thiol. So the first one is oxidation. So thiol goes up or show an oxidation reaction and they form a disulfide bond. Means 2 sulfur atom is attached through a bond. This is why it's called disulfide bond, which are an important structural feature of some proteins. So whenever we are going to talk about proteins in the next couple of lecture or in the upcoming lecture, you will see in protein you have a disulfide bond. So this is very important reaction, oxidation. So the general reaction is, this is thiol group. When you have any thiol group attached to the carbon, this 2 in the front saying you have 2 thiol group, means RSH plus RSH. You have 2 thiol group, and when we perform the oxidation reaction, what's gonna happen? So let's make this thiol group like this, thiol group plus oxygen. Right, so what's gonna happen? Hydrogen from each of the thiol group can combine with oxygen to make this water, H2O. And what else left? You're left with RS and SR, and they're gonna combine together. RS, SR, they're gonna combine together to make a disulfide bond. So remember this thing, whenever you oxidize, you're gonna make a disulfide bond. Let's take this example. This is methane thiol, right? And you have 2 molecules of methane thiol. So when you oxidize 2 molecules of methane thiol, you're gonna remove water, right? You have 2 hydrogen, 1 from each molecule attached with the oxygen. You're gonna make hydrogen and oxygen into a water, and then the rest of the atom is gonna combine together to make a disulfide bond. Right, so remember, oxidation always form a disulfide bond in thiol. Okay, so the second reaction is reduction. Like we have oxidation, similarly we have reduction. So in reduction, we're gonna just introduce or put hydrogen again back to the disulfide bond. So what's gonna happen? This is your disulfide bond. This is the oxidation product. When you introduce the hydrogen, what's gonna happen? This bond is gonna break and each hydrogen is attached to the respective sulfur, and then you're gonna get 2 molecules of RSH. Right, so let's take in this example. This bond is gonna break, 1 hydrogen is gonna come over here, and then you're gonna make 2 molecules of CS3H. This is CS3H. Now this is CS3H. So that means 2 molecules of CS3H. So you're converting the oxidized product back into a reduced form, which is a thiol form again. Right.